Our kidneys are remarkable organs. They work silently, day in and day out, to filter waste products and excess fluid from our blood, keeping us healthy. They are essential to maintaining the body's delicate chemical balance. When someone experiences kidney failure, also known as end-stage renal disease, these vital filters stop working effectively. This means harmful toxins, waste, and extra water can build up to dangerous levels in the body. If left untreated, this condition can be life-threatening, making it crucial to find another way to perform the kidney's essential job. This is where a truly life-saving medical procedure called hemodialysis comes into play. Hemodialysis is a treatment that takes over the function of the failed kidneys. Think of it as an artificial kidney that works outside of your body. It is the most common method used to treat advanced and permanent kidney failure. The primary purpose of this procedure is to clean the blood, removing the waste products that would otherwise accumulate and cause serious health problems. It also helps control blood pressure and maintain the proper balance of important minerals in the blood, such as potassium, sodium, and calcium. For countless individuals, hemodialysis is not just a treatment, it is a lifeline that allows them to continue living. The need for hemodialysis arises when the kidneys have lost about 85 to 90% of their function. At this stage, they can no longer keep up with the demands of the body. Without this intervention, patients would suffer from symptoms like severe fatigue, nausea, swelling, and confusion as toxins build up in their bloodstream. By stepping in to do the work the kidneys can no longer handle, hemodialysis provides a critical bridge, sustaining life and helping patients feel better. It is a testament to medical innovation, offering hope and stability when a vital organ system fails to function. Therefore, understanding hemodialysis begins with appreciating its fundamental role. It is a substitute for a natural process that has gone wrong. It does not cure kidney disease, but it manages the condition effectively, allowing people to lead more active and fulfilling lives. The treatment requires a significant commitment from patients and their families, often involving multiple sessions each week. However, this commitment is what makes it possible for them to manage their health, prevent complications, and look forward to the future, even with a chronic condition. It is a powerful tool in modern medicine. So how does hemodialysis actually clean the blood? The process relies on two key scientific principles: diffusion and ultrafiltration. Let's start with diffusion. Imagine making a cup of tea. When you place a tea bag in hot water, the concentrated tea particles naturally move from the bag into the surrounding water until they are evenly spread out. Diffusion in hemodialysis works in a very similar way. It is the movement of waste products from an area of high concentration, the patient's blood, to an area of low concentration, which is a special cleaning fluid called dialysate. During treatment, the patient's blood flows on one side of a thin, porous membrane, while the dialysate flows on the other side. This membrane, known as a dialyzer, has tiny holes that are large enough to let waste products like urea, creatinine, and potassium pass through, but small enough to keep important things like red blood cells and proteins in the blood. Because the blood is filled with waste and the dialysate is clean, the waste naturally diffuses across the membrane and into the dialysate, which is then discarded. This is the primary way that hemodialysis purifies the blood of toxins. The second important principle is ultrafiltration. While diffusion takes care of the waste, ultrafiltration is responsible for removing the excess fluid from the body. Many people with kidney failure cannot get rid of extra water, which can lead to swelling, high blood pressure, and strain on the heart. Ultrafiltration uses pressure to gently squeeze this excess water out of the blood and across the same membrane in the dialyzer. A pressure gradient is created, pushing the fluid from the blood into the dialysate solution, effectively and safely reducing the fluid volume in the body. Together, diffusion and ultrafiltration replicate the main functions of healthy kidneys. Diffusion cleanses the blood of harmful metabolic waste, while ultrafiltration removes the excess water that the body can no longer excrete on its own. The hemodialysis machine carefully controls both of these processes, ensuring that the right amount of waste and fluid is removed during each session. By harnessing these simple physical principles, the technology offers a highly effective way to restore balance to the body when the natural systems have failed, providing much-needed relief and stability for the patient. The hemodialysis system is composed of a few key parts that work together seamlessly to clean a patient's blood. The central component is the hemodialysis machine itself. This sophisticated device acts as the control center for the entire treatment. It pumps the blood from the patient, guides it through the artificial kidney, and then safely returns the clean blood to the body. The machine also monitors important vital signs like blood pressure and heart rate, and it ensures the temperature, pressure, and composition of the cleaning fluid are precisely correct. It is equipped with alarms to alert the medical team to any potential issues. The heart of the cleaning process is the dialyzer, which is often called the artificial kidney. This is a large canister containing thousands of tiny hollow fibers made of a semi-permeable membrane. During treatment, blood flows through the inside of these fibers, while the dialysate solution flows around the outside of them. This is where the magic of diffusion and ultrafiltration happens. The dialyzer is a single-use component. A new one is used for every treatment session to ensure sterility and maximum effectiveness, preventing any risk of cross-contamination between patients. The third critical element is the dialysate, or the dialysis solution. This fluid is a carefully prepared mixture of purified water, electrolytes, and minerals. Its composition is customized for each patient based on their specific needs, as determined by their blood tests. The dialysate is what allows diffusion to work properly. Since it contains no waste, it creates the concentration gradient needed to pull toxins out of the blood. It also contains beneficial substances like bicarbonate, which can help correct the blood's acidity, a common problem in kidney failure. The machine constantly prepares and circulates fresh dialysate throughout the session. Finally, none of this would be possible without a way to access the patient's bloodstream. This is known as a vascular access. This access point needs to allow a large volume of blood to be withdrawn and returned quickly and safely. The most common types are an arteriovenous fistula, or graft, which are surgically created connections between an artery and a vein, usually in the arm. For more temporary situations, a central venous catheter may be used. This access is the patient's lifeline, connecting them to the machine that keeps them healthy. A typical hemodialysis session is a well-structured routine that patients become very familiar with over time. It usually takes place in a hospital or a dedicated dialysis center. The process begins with preparation. Upon arrival, the patient is greeted by the healthcare team, and their weight and vital signs, such as blood pressure, pulse, and temperature, are checked. This initial weigh-in is very important because it helps the team determine how much excess fluid needs to be removed during the session. The patient then settles into a comfortable chair where they will remain for the duration of the treatment. Next comes the connection to the hemodialysis machine. The dialysis nurse or technician will carefully clean the area around the patient's vascular access. 2 needles are then inserted into the access point. 1 needle is used to draw the blood out of the body and send it to the dialyzer for cleaning. The other needle is used to return the newly cleaned blood back to the body. While the needle insertion might cause a brief moment of discomfort, it is generally well tolerated. Once the needles are securely in place, the tubing is connected to the machine and the treatment begins. The actual cleaning process typically lasts for about 3 to 5 hours. During this time, the patient's blood is continuously circulated through the machine at a steady rate. Most patients use this time to relax, read a book, watch television, work on a laptop, or even take a nap. The dialysis machine works quietly in the background, and the nursing staff is always nearby to monitor the patient and the equipment. They regularly check blood pressure and make any necessary adjustments to ensure the treatment is proceeding safely and effectively. The goal is to make the experience as comfortable as possible. Once the prescribed time is up and the right amount of fluid and waste has been removed, the session is complete. The machine is turned off, and the needles are carefully removed from the vascular access. A sterile dressing is applied, and pressure is held on the site for several minutes to prevent any bleeding. The patient's weight and vital signs are checked one last time to confirm the treatment was successful. Many patients feel tired after a session, which is a common side effect. After a brief rest, they are ready to go home, with their blood chemistry restored to a healthier balance until their next scheduled treatment.